Hello favorite students. In this video we are talking about the connection between our forces model and our constant acceleration model. So earlier in the school year we learned about the constant acceleration model. It has these three equations that we used OK Team to solve. This week we've been learning about the forces model using F equals ma. We now have a connection between these two models, and that is acceleration. The acceleration that we see in F equals ma is the same acceleration that we see in our constant acceleration model equations. So if we divide both sides by m, and we get acceleration equals net force divided by mass, we can then take that acceleration and plug it in into any of our three constant acceleration equations. Or, if we used these equations to find acceleration, we could plug it in here to find force or mass. So to do an example, we're going to look at page 38 in your Unit 2 Red Workbooks, question number 1. This is talking about a car speeding up, and we want to know the force acting on the car. We're always going to have two steps when we're solving these problems, similar to projectiles. The first is that we need to find acceleration, and then we're going to find whatever the actual target is in the question. And we want to use F equals ma one time and OK Team one time. So if we find A using F equals ma, we'll want to find the target using OK Team. Or, if we find A using OK Team, we'll want to find the target using F equals ma. In this problem, our first step is going to be to use OK Team to find A, and our second step is going to be using F equals ma to find the force, because the force is what the problem is looking for. So I'm going to start with my givens. I know my starting velocity is 0 meters per second. My starting position is 0 meters. My final position is 40 meters. My time is 3 seconds. And my target in this part of my problem is acceleration. I'm going to choose the second equation because it has all of my givens and my target, and it does not have anything that I don't have. I plug in my 0 for starting position and my 0 for starting velocity, and that gives me final position equals 1/2 acceleration times time squared. I then multiply both sides by 2. I get 2x equals acceleration multiplied by time squared, and I divide by time squared to get acceleration equals 2x over t squared. I'm then done with part 1. I take that acceleration and I plug it in here into F equals ma. So then I have F equals m times 2x over t squared, which is what my acceleration value was here. This is my final answer if I want to leave it in variable form, or if I want to solve for the numbers. I'll plug in 710 for the mass, 230 for the position, and 3 for the time. And when I did that math, that came out to be 4,733 meters. So hopefully that helps to see the connection between forces and acceleration. Be the leaders that your community needs and deserves, choose to be great, and have a great day.